What is the condition for conservation of angular momentum? The claim that we made about angular momentum is that if you have a torque applied to a system, it is equal to the time rate of change of angular momentum. And one way that this makes sense is if we apply this specifically to rigid body rotation, which we don't necessarily have to. It turns out this statement is not necessarily restricted to that, but let's look at that because I think it will make things make a little more sense here as to why this should be true. If angular momentum is really equal to just moment of inertia times angular velocity, then if I think about the change of that, and the moment of inertia is a thing that's not changing, you might recall we did something kind of similar with ordinary momentum where we said, hey, delta mv wound up being m delta v, right? Well, delta I omega, since I is constant like m was in the analogous case for ordinary momentum, then this would be equal to I times delta omega all over delta t. But I could look at that, I could rearrange things a little bit here and just put the two delta things, right, in their own ratio. I think that's mathematically legal to do that. But delta omega over delta t is really angular acceleration. Oh, and this is just Newton's second law for rotation. So this at least gives some credibility as to why this way of looking at angular momentum might be correct. It's also the way to answer this question. If I multiply both sides of this by time, I would get torque multiplied by time is equal to change in angular momentum. But if the torque happened to be equal to 0, that would imply, right, that, let me state this a little bit differently here. So what I'm trying to say, let me change it here. Oops. Trying to say if this is true, then this is true. I just didn't like the way that was going to turn out. So to say that more clearly is if torque is equal to 0, that implies that delta L is equal to 0, which implies that L final minus L initial is equal to 0, which implies L final is equal to L initial, which is probably the most basic statement for conservation of angular momentum. So hence the condition is that the overall torque on the system, maybe you could say net torque on the system, must be equal to 0 to have conservation of angular momentum, which makes it theoretically possible to have this be true for a system that is maybe not closed in all ways, but simply closed to external torque being applied to it.